Here's the answer for day 4, problem 1. Find the missing length indicated by the question mark symbol. And we're told that the triangles are similar. So here's where the question mark symbol is. We're looking for segment KJ, or the bottom of this smaller triangle. What we have to work with is the length of the hypotenuse of the small triangle. And in the larger triangle, we have the hypotenuse, and we have the length of the side, which corresponds to the side we don't know. We're told that the triangles are similar, so we can create proportions matching the corresponding parts. It would look like this. The question mark is to the 33, as the 28 is to the 42. Now let me show you where I got these numbers. I'm taking the bottom of the small triangle and using a ratio comparing it to the bottom of the large triangle. Bottom side compared to bottom side. That's why I said these are corresponding sides. Then I'm taking the hypotenuse of the small triangle and comparing with a ratio to the hypotenuse of the large triangle. Hypotenuse compared to hypotenuse. Again, corresponding sides. When you take those two ratios and you put an equals between them, that is called a proportion. And we can solve that proportion with cross multiplication. 42 times the question mark equals 33 times 28. To get the question mark alone, now divide both sides by the 42. When that 42 cancels away, you notice the question mark is now alone. On the right side, we could type this in a calculator or do this by hand, however we want to get the answer. It's 22. So we figured out how long the bottom of the small triangle is by using these other measurements. Now, day 4, problem 2. Find the arc measure indicated below. We're looking for the measure of arc CFD. When you use 3 capital letters to name an arc, the first letter in the name is telling you where the arc begins. The last letter in the name is telling you where the arc ends. And the middle letter in the name is telling you that your arc is more than 180 degrees. If this was only called arc CD, it would go from C to D and be this short arc here. But because it's called arc CFD, we have to go around this direction so that we're passing through point F along the way to the end point. See, right there we finally reach F. And then as you keep going, we'll eventually get to the end point, point D. We're asked for the measure of the arc. Well, all the way around a circle is 360 degrees. This arc doesn't go all the way around a circle, but it goes quite a ways around. We're looking for a fairly large measurement, but something less than 360. What we have to work with are some angle measurements. This is 81 degrees here, which means that this arc here is 81 degrees. And this angle is 135, which means that from here to here is 135. We want to find this whole distance. Here's how we could do it. Do you notice this straight line running all the way across the circle? That angle and that angle have to be 180 degrees. So this missing piece in here is 45. 135 plus 45 is 180. Next, this angle and this angle are vertical angles which are congruent, so this is 45 degrees. Now I have all of the pieces of information I need to find arc CFD. We need to add up all these pieces. 45 plus 135 plus 45 plus 81. That'll get us the measure of the arc. So 45 plus 135 plus 45 plus 81. Type that in a calculator and you'll have the answer. It's 306 degrees.